Hello class, in this lecture I will talk about hypothesis testing using t-statistics. So the first thing of hypothesis testing using t-statistic is when do we use t-statistic? T-statistic is usually used when your sample size n is less than 30 and your population standard deviation is unknown. So that is when we will be using t-statistic. So we will try to solve a problem uh, using t-statistic, and in this problem I will be mostly doing two-tail. So the problem is a president of a university claims that the weight of the students in the university is 160 pounds. So now this is kind of the claim that is made by president, and you wanted to determine whether this claim is true or not, so you will conduct a hypothesis testing. So when the president claimed that it is 160, that means they are saying mu is equal to 160, so they are saying this is exactly equal to 160. So in hypothesis testing, the first step of hypothesis testing is define hypothesis. So this is a two-tail problem because this is exactly equal to 160. So alternatively you are saying it's not equal to 160, so you can disprove the precedent on both sides of the normal distribution curve. So this is mu is equal to 160. Your alternate would be mu not equal to 160. So once you have an hypothesis, you will collect the data. You will go to the university and collect a sample and see whether that sample justifies the president's claim. So this is all given. So you collected a sample of 16 students, and your mean weight of those 16 students x bar is 163 pounds, and then the standard deviation of those 16 students would be 5 pounds, and you wanted 95% confidence interval or your significance level. So this is alpha is significance level alpha, so is 0.05. So all this will be given. So the second step, so this was the first step of hypothesis testing. So the second step of hypothesis testing would be to compare test statistic with critical value. So the test statistic, so now which stat to use, whether to use Z or T. So you use Z when your sigma is known and n is greater than or equal to 30. So here your n is 16 and you have S given rather than sigma, so you will be using T stat. So this is T. This is used when n is less than 30. So 16 is clearly less than 30 and your sigma is unknown. So the formula for T stat is x bar minus mu S over root n. So your x bar is x bar is 163. So 163 minus mu. Mu is mu is 160. So you will do 160 minus. So I will use the same color. 163 minus 160. S is 5 over n is 16, square root of 16. So this is going to give me 2.4. So now the second step of this is to determine the critical value. So the critical value, because your hypothesis, if you see, your hypothesis mu is equal to 160 and mu not equal to 160. That means you will be able to disprove the precedent on both sides of the normal distribution curve. What it means is, if it is less than 160, then the precedent's claim is wrong. If it is more than 160, then the precedent's claim is wrong. So that is that's the reason why this is a two-tailed problem. So to do critical value, I will write critical value. So I will do the calculation here. So this is a two-tailed problem. So I have a normal distribution, and then there will be, this is 0.95 confidence interval. So here mu would be 160. So this is the precedence claim, and anywhere in between these two, so this area, this whole area, the precedence claim is true. So that means this is do not reject H null. So when I can't reject our null hypothesis, that means the precedence claim is true. And then these areas is where I can reject precedence claim. So this is reject H null. That means the precedence claim is false. So this area would be, so because this is 0.95, this area plus this area would be together 0.05, and then this area would be half of it, that is alpha over 2, which is 0.025, and this will be 0.025. This is again alpha over 2. So since it's a two tail, we will be using alpha over 2. So this is T alpha over 2, and then the degree of freedom is n minus 1. So this value, if you see, alpha over 2 is, we got 0.025, and then n minus 1, our n is 16. So you would do the degree of freedom of, so this is degree of freedom df. So this would be I think it's 16 minus 1, which is 15. So you are looking for t 0.025 and 15 in your t table. So you will be looking in your t table for this value. So usually t table, if you see, it gives, the t table is going to give you right of the curve, right side of the curve. So that means it's going to give you this point t 0.025 and 15. So this is the probability you will be using, which is 0.025. So I will now go to t table and calculate what is this. So I'm now going to our course modules, and then I will go to calculation aids, and then look for statistical tables. So currently I am in Poisson table and I have to go to t table. So this is t table and I am looking for t 0.025, and the degree of freedom I think is 15. So let me cross check. So I am looking for t 0.025 and the degree of freedom is 15. So let me go to our t table, and t 0.025 is this one, and degree of freedom 15 is this one. So our value will be 2.1314. So that is our critical value. So I will go and write that. So let me, okay, so this is 2 point, so this value here 2.1314. so this will be negative 2.1314. so those are our critical values. So now I'm going to compare, this is the comparison I'm going, where does 2.4 lie in this normal distribution curve. So I can go here, and I know this is 2.1314, so I'm looking for again 2.4. so 2.4 will be somewhere here. So this value will be 2.4. it will be on the right of 2.1314. so that means it lies in the rejection region. So that means we are rejecting H null. So what it means is, this is, the president's claim is false because we are rejecting that claim. So the statement would be, so this would be reject. The statement would be to this is how you will write a statement: there is insufficient evidence to claim that the weight of students in the university is 160 at 95% confidence interval. So that's the statement you will be writing. So let's do this same problem using our calculation aids and see if we can do this problem. So this is using calculation aids. So let me note down the question here. So we know our hypothesis is mu is equal to 160 and alternative is mu not equal to 160, and it is a two-tail problem because it's exactly equal to. And then the given data. So I'm just copying these the question values, this whole thing. I'm just copying this whole thing for our purpose. So n would be n is 16 and then x bar is 163. The sample standard deviation is 5 and alpha is 0.05. Again, n is less than 30 and then sigma is unknown here. So we will be using t-stat. So that means we are using unknown variance sheet in our calculation aid. So I will go and download our calculation aids and try to solve this problem. So this is chapter 10. So I have this. Currently I am in proportion test calculation aid. I will go into mean test unknown variance and I am looking for which case to use, and as you know our problem is a two-tail test. So our problem is a two-tail test because this is exactly equal to. So I will use two-tail. So this is H alternative not equal to, if you see, that is what it is saying. I will use this case 3. So population mean. So let me go and check what is the population mean. So that is given as 160. So I will type in 160 there. So this is 160 and then population mean or sample mean. This is sample mean. So I will go and look for sample mean x bar. X bar is given as 163. So I will go and do 163 here, and then sample standard deviation S, that is 5, S is 5, and then alpha is 0.05, so I will type in alpha as 0.05, sorry, 0.05, and then finally sample size, I think it is 16. Let me cross check it. So this is n is 16. So if you see, we got a critical value of 2.4, no, test statistic value of 2.4, critical value of 2.131. So you are rejecting null hypothesis. So that's how you are going to solve these kind of problems. This concludes my lecture on T statistic. In the next lecture, I will talk about one-tailed T statistic, where I will try to solve a Hawk's problem. Thank you.